Hello, I've got my hands on one of these bad boys. This is a Raspberry Pi 02W. It's been on the market for a few months and it's got more computing power than a 0W, so it's the equivalent of a 3A+. So over the next few weeks, I'm going to be looking at some of the robot builds I've made and see how well this 02W does in place of their existing Pi. I've been a bit ill, so excuse the scratchy throat. So two great projects to focus on with this are the Low-Cost Raspberry Pi Robotics series that I did with MagPi, or the other alternative is this, which is the robot build for Learn Robotics Programming. And I guess this robot right here from the second edition, I used the Raspberry Pi 3A+. You can just about see it under there, because of its size, because of its processing power, and because of its power requirements. But I reckon the 02W is an excellent alternative. The Zero itself, I thought, or the 0W didn't quite have enough power for all of the fun visual, computer vision experiments we're going to do. But the 02W should have the same power, roughly, as a 3A+. Note that right now the 02W is a bit tricky to find, so the 3A+ is still a great choice. So in this series, I'm going to actually start with this book. I'm going to look at some of the chapter exercises, basically on the Raspberry Pi, and see how they work with this board. Now, I'll look at the differences in the board, the mounting, the things with the camera, so we'll have to adapt the camera, and also differences because there'll be changes to libraries. There'll be newer versions of the Raspberry Pi OS as well, because, although this book is, about a year old now, a year in time of making robotics is a long time. It might as well be aeons, so we can go into some of the changes. Although the basic structure is the same, all the libraries will be slightly different. So I'll share where I get into trouble and what solutions I come up with, and I'll maybe stage some branches of the existing Git repos for these so you can actually kind of pick up on what I've done with it. And then we can repeat the experiment from this robot onto the other robot, the MagPi robot, and you never know, I can see how it fares in other builds of mine. I mean, a 02W is going to make sense in a lot of places, unless, of course, the existing Pi is enough. But hey, why not upgrades? So let's get started. So look, before we get into soldering it, one thing I wanted to do was go and compare the two. So I've got here, I think this is a 0W. Let's just get into focus. Raspberry Pi 0W, so that's a V1. And the Raspberry Pi 0W V2, I guess this is going to say. So right off the bat, that layout is similar. The SD card's in the same place. The chip is quite a lot bigger. And I'm guessing, I don't know what that is, but that's a huge chunk of stuff. We've got the same connectors, so it hasn't changed to a USB-C or anything like that. So they look fairly equivalent, the same camera connector. All of the mounting holes are in the same place. So to some degree, one will drop straight in where the other was, without much hassle beyond in software. That's kind of cool. This looks like it's made by, is it a different manufacturer or is that just the light? I don't know. No, it looks the same. Okay, that's just a trick of the light. And can we see, if we can get it to focus on it. Is it going to give me some, got some FCC IDs and so on. Copyright, is that 2016? And then this one is going to be what, copyright 2022 or 2021, there we go. All right, and it's got this QR code. I don't think the other one had a QR code on it. No, it didn't. Okay. All right, and you see, what is this extra pad down here? That doesn't look like it's the camera pad. That looks like it's something else, but they both have it. Oh, well, if you know, answers in the comments, you can tell me what that is. I mean, the bottom looked like test pads, all of these gold bits here. And I think there was a project to Kickstarter, is it called the Notix, I think, that actually took advantage of some of those pads to give you some stuff you could plug in. Like, I think it was like a USB serial straight in jobby for a Zero. I guess you get serial instead of some of the OTG things. So we'll talk about that later, but this has all the Zeros have a superpower, they're OTG, and we'll get into that. I kind of like it. Okay, right, soldering. So if I was lucky, I would have an exact fitting header from some of the other projects left, but I have actually used all the ones for the Raspberry Pi, at least the ones that aren't, female headers or something else, or right angle headers. So I've either got this straight 2x whatever, or I can take these 1x whatevers and break them off. And I think I'm going to break these off instead. I don't know, I just feel a bit reluctant to break into this one. I don't know, I have that feeling. One trick I can do with breaking headers off is pop them in where they're supposed to go, get my nail in just after there. There we go, and I should be able to snap my nail off. It means I don't have to measure it, it'll just kind of, there we go, nice and easy. And if I'm lucky, that will almost fit exactly with it. Come on. There we go. So that was an almost exact fit. Now I'm not going to put it in this way, that would be upside down. I'm going to put it right side up. I'm not quite that crazy yet. And we'll put it in that way up. There we go. And that's how we're going to solder them in. So because there's two separate lines and one double line, we'll do each as a separate line just to save ourselves a little bit of the trouble of keeping it all together, which is fun at the best of times when soldering. The 3A Plus came with headers included, and the 0 series, they don't. The first thing we're going to do is a step that is not in the books, which is to solder these headers in. I have tried out hammer headers. Possibly they're good for those who are nervous about soldering, but to be fair, I prefer soldering because I actually fear hitting hardware with hammer more than I really fear soldering. So what are we going to need? Well, we're going to need the 02W, obviously, and the headers, 2 rows of 20, which I've got here. We're also going to need a soldering iron. Now, I think it should be a temperature controlled iron like this one, and the smaller ones, so this one's quite reliably. This one comes with a stand. If it does not come with a stand, please get a stand, even if you're using one of the pencil type, especially if you're using one of the pencil type. Get a stand, otherwise you risk burning yourself, setting fire to your desk, all of those horrid things. Get yourself a fume extractor. I consider this not optional because, I mean, my throat's scratching, not because of soldering, but it could be because of soldering, because the fumes from soldering, they are nasty. And I'll turn this on a bit later because the noises, it does drown me out when talking a bit. So that and some solder. So we need solder like this one, which is lead free. This one is some 6040 solder. Something to clean your tip off on. I tend to like this stuff. Some people like the wet sponges. I prefer this. I think it's better for your tip. So you'll also, I like this tip tinner cleaner. This is kind of in the optional territory. You do need to tin your tip, and you could just tin it with your solder. I like to tin it with this because it cleans it as well as tinning the solder. And that means, tinning means sticking a little bit of solder on the end of your soldering iron just before you're ready to go, just to make it, can transmit heat well. I guess where you've got an air gap, even a tiny one doesn't transmit heat. Solder transmits heat well. So I tend to have this in the in this lovely tray that's normally for the sponge because I can't stand the sponges. So now we're well into optional. Solder sucker, this helps deal with any mistakes, sucking out. Now, more often than not, you can get around a mistake just by dragging the iron over, but I like to have this around, solder sucker, and I like this engineer model. It's rather nice. In the almost optional, but not quite, goggles, okay? To be fair, okay, Raspberry Pi headers are an easy job. It's not like some of the other bits where, especially when you've got capacitors and things, you're clicking off the leads. You want goggles because those leads will ping off your face sometimes. But, you know, it's worth getting the habit. Flux in solder can sometimes spit. I have had it spit on my hands. And, you know, your eyes, keep your eyes safe. We're also going to need some gear to hold this into place. I'll come up with some of that in a minute. But my general go-to for this is to actually just use a breadboard, because you really don't want the headers of the board to move when you're soldering. It can make for really bad solder joints if it moves. And if it moves unexpectedly, moving you or the iron, it puts you at risk of burning yourself, damaging the board. So yeah, an extra breadboard is probably my favorite go-to for this. Right, I guess we'll go and get started. Oh, one other thing of note. This board has been, and if you can just about see this, it's been V-scored out. That means there was perforations between boards and they've been cut out. If you look at it, there is a nasty little hairy thing there. If you get that in your fingers, it will itch and hurt for days. So just beware of that when you're handling these, and you really don't want to brush your finger along the edge there. You could very carefully go along it with a little bit of sandpaper or a bit of file, just really light touch, but you just want to take off those dags, because if you don't take them off with something else, it might be your thumb that takes them off, and that's no fun at all. So just because I had it handy, I'm going to give it a light touch with this file and try and keep it in shot when I do so. Just this much really, it doesn't have to be, we're not trying to do a decorative job here, we're just trying to take off this horrid stuff. And look, it's, there we go. I can see it's actually ended up on the pie chips themselves. Lovely. Maybe I'll get something to blow that away with. Here's a camera lens blower, not a normal soldering tool, not one I use full soldering, but I do use to blow stuff away from chips, partially because I don't want to get my mouth in there, because I don't really want moisture from my mouth getting in there. And if I go and blow in there with my face in it and that stuff blows in my face, gets in my eyes, that's going to be a real bad day. So I'm just going to use this. Yes, maybe I'm a little bit over safety conscious, but I like my eyes a lot. Right, while not perfect, you'll see that that hairy thing has gone. Oh, there's another one there. You can see it, that evil thing there. You can see that, that's going to get caught in my fingers. So let's get rid of that too. And this is probably worth doing for educators doing stuff with children, just a little bit, because you really don't want children getting these things in, because if they run their fingers along the edge there, they're going to end up with that stuff in their fingers. And it only seems to be the one edge, because the other edge doesn't appear quite so bad, I guess. It's kind of hidden by the connectors though. The ends aren't too bad, and I think the old ones, maybe just the way they were manufactured, I didn't see it as much. Oh no, look, there it is. I can see it right there. You see that? Yeah. So it is a problem. And you'll find this with a lot of electronics and a lot of boards. If you get, you know, various kind of sensor modules and power modules, as well as the Pi, they'll have this same problem, and you need to probably take the same care, because again, it's not very often you'll end up with your fingers, but when you do, you'll really know about it. It's a day later, and I've determined that actually I'm about to have a whole bunch of problems with the solder not sticking properly. And that's because after I filed this, I didn't really wipe it down. I just blew the stuff off a bit. So the dust on here, any dust, is going to make problems when you try to solder things. And after filing, that dust is particularly bad. You watch. It's much trickier than I thought it was going to be to solder it. Okay, I'm going to pop this in this rather oversized breadboard. I'm not putting it all the way down. I just want to kind of prop it up so it doesn't move a lot. That will do. Now, the straighter I get this, the straighter it will be when I'm done. So we'll just look down the edge there. And what I'm doing there, it's quite hard to get the camera to see, so I'm more worried about the alignment of that. You see, the connector to the Pi. I don't care whether the Pi is square to the board, I care about whether the Pi is square to the connector. So to solder, and this is going to make the noise quality a bit worse, I'm afraid, I need to turn on this fan. And that, just making sure I'm not going to be sucking down the fumes. Now, just because my desk is a bit cramped, I can't get it close to where I am soldering, but ideally you'd have it right there. And to solder. So first I need to tin the tip. So you'll notice the tip isn't looking that sparkly and shiny. So we get it in this tip tinner. Again, you can just do this with some solder. I'm going to tip it in this special tip tinner. And once it's started to get melty, then I will stab it in here with a nice shiny tip, which means we are ready to solder. So we'll do each end first, and we'll start at these ends just to tack the thing in place. So you've got a pad, you've got a pin in the pad. You use the iron to heat the pin and pad from one end. And then you feed the solder in to the pin and pad. Now the tipped tin should be transferring heat from the iron to the pin and pad, and then the pin and pad transferring heat from the iron from the iron's tip through the heating pad to the solder. So it's not, the solder here should never be touching the iron, should only be touching the pad. These are, there we are. Alright, let's get a bit closer because you can't really see that. So what I tend to do is tack one side on, and we'll just check. There we go, that's in nicely. Let's get the camera in. And although that's not aligned to the board, it is aligned between the Raspberry Pi, but that's not the best joint. A little bit blobby, and really want a nice tent. Let's try and get a better joint on this side, and I can always reheat a joint that isn't perfect. So we'll heat these up. Once they're hot, we'll feed solder in, and voila. Okay, and now what I can do is just work along the rest of the pie, doing the same. Oh, my solder reel is snagged. So look, here there's a bit too much. I can just wipe it off with the iron, no problem at all. And I'll just stab it in there. Then, to be honest, once you're going, you almost kind of get a rhythm to it. Now, it probably goes without saying, but you don't want to be putting your fingers very close at all to the iron. Some pins, especially those that are ground pins, may take a bit more time to heat up than others. I'm just going to flow that one better. There we go. Now this one here, I ended up with a bit too much solder here, so I am just going to suck that away. Let's try not to hit the camera with it. I guess the next job is to tack the other row in and go along and do the same. This breadboard will take it. I want to press it in slightly because, there we go, right, we'll do it like that then. Breadboard has more mass than the Raspberry Pi, so it doesn't shift so much. You see, I don't particularly like this joint over here. Just going to heat that joint up and add a little solder in. What you really want, by the way, is nice conical tent or teepee-like shapes. Not, you don't want bulbs, no spheres, no round blobs. That doesn't have any flux in it. So the smoke comes from flux, which is this stuff that's smoking off there. And flux kind of cleans a joint before the solder sticks to it. Look at that, that's a terrible job. Did I say I was actually any good at this? There we go. Now we can have a closer look and try and improve these joints, because I've seen better. Look at that. That's taken the solder up with it. Wicked it away with the iron. See, I don't want that either. I'll just reflow that one. Alright, those are all done, but since I'm here, I've got this other 0W, not a 02W, and I'm probably just going to solder that as well. So, a lot of the same techniques apply. I'll pop the header in, like that, find the end, like that, and break it off. I'm going to try it another way. Let's see what happens if I stick both header rows in this breadboard first. What happens if I try both at the same time? Like that. Okay, let's zoom out slightly. We'll do these end pins first. Is it me, or is there slightly more to solder onto on these pins than there were on the 02W? I don't know, maybe it's just me, but I just feel there's a bit more in those pads. And that's not a good sign. I am smelling the flux fumes, which means it's coming to me and not the... Oh, look at that. That bit of the blob of solder came from under my iron. It's on a test pad, so it won't do any harm, but still, it's not really right, is it? So, are they perfect? Far from it. Are they good enough to get the job done? I think so. We've now got a Raspberry Pi ready for the next step, which will be installing an OS, which we'll do headlessly in the next video. You can follow along with the coming experiments with Learn Robotics Programming Second Edition, available on Amazon and Pact Publishing, where I take a reader from limited robotics experience through the steps to build a robot with colour tracking and face recognition, mobile phone driving and camera remote driving, automatic obstacle avoidance and line following. You can start your robotics journey with Learn Robotics Programming Second Edition. For now, go make stuff and be awesome. Bye!
A day later, still some debris from the from filing in there.
Down here. See, but here's the thing. Without the breadboard, you can see it's moving away from me. Yeah, we still want the breadboard. It's just a bit trickier because now there's two rows. So two great projects to focus on are my low-cost Raspberry Pi Robotics series. We have a Raspberry Pi 0V1 and a Raspberry Pi 0V2, inexpertly soldered by me, but I think ready to use. So it's a day later and I've got this